What's going on, guys? Let's try this problem right here. This question is asking find a power series for the function and determine the radius of convergence. Here we have this function, but usually when we have a function and if we want to convert that one into power series pattern, we use this one, that is 1 over 1 minus x, and that is equivalent to sigma n is equal to 0 to infinity x power n, and that's it, right? So this is the one we use. Now in order to do this one, we have to have this kind of pattern, right? But here we don't have that pattern, we have something else. Now we have to bring this one in this pattern. How can we do that? If you think about this tan inverse x square, but tan inverse x, if you take the derivative of tan inverse x, you will get 1 over 1 plus x square, right? So we can use this information in order to, so this is derivative, let's say tan x prime, right? If you take the derivative of this one, you will get this one. But if we want to express this one in terms of this, we have to show that tan inverse x is integration of 1 over 1 plus x square, because if you integrate this one, you will get this one back, right? So this is same as this one. Now we have this kind of pattern, but in order to do this, in order to convert this one into this pattern, we have to have a negative sign, right? But here we don't have that. So to bring the negative sign, what we do is we take this one, integration 1 over, we can write this one as 1 minus x square. Now whatever the value we are subtracting, that's going to be powered by n. If you notice this one, whatever the value we are subtracting, here we are subtracting x, so that's one powered by n. Here we are subtracting negative x square, so this is going to be powered by n. So if I write this one in terms of power series pattern, this is going to be integral of 1 over 1, not 1 over, actually sigma n is equal to 0 to infinity. So here we are subtracting negative x square, right? So we have to bring negative x square right here and power this one by n. And let's simplify. So this is going to be sigma n is equal to 0 to infinity. We can take this negative sign to the front. So this is going to be negative 1 powered by n x power 2n, right? Now we have to integrate this one to get this one, right? So if we integrate this one, this is going to give us n is equal to 0 to infinity. So we also have to put dx right here, dx. So dx. So this means x is the only one related to integration. Other thing is not going to change. So x, what we have to do is we have to add 1 more to the power and divide by that power. So here we are going to have negative 1 power n x power 2n plus 1, and then we have to divide this by 2n plus 1. Now this is only tan inverse x, right? This is equivalent to tan inverse x. Now in the original equation we have tan inverse x square. Now converting this one into x square is easy, because all we have to do is plug x square instead of x. Now let's see. So after we done this, we don't need this information anymore. Let's get rid of this part. Okay. So now we have found out tan inverse x in power series pattern. Now we have to find tan inverse x square in power series pattern. Tan inverse x square is going to be sigma n is equal to 0 to infinity negative 1 power n, and instead of x we plug x square, because previously we had x, that's why we have x. And if we want to plug x square, we have to just change this one into x square power 2n plus 1, and the denominator is going to remain the same, that's going to be 2n plus 1. And let's simplify. This is going to become sigma n is equal to 0 to infinity negative 1 power n, and this is going to become x power 4n plus 2. and in the denominator we are going to have 2n plus 1, right? So now we have converted this one into this pattern. This is the first question. Find a power series. Now we have found it. Now the second question is asking determine the radius of convergence. To find the radius of convergence, what we do is we take the ratio test. Ratio test is this one. Limit n approaches infinity, absolute value an plus 1 over an. So an plus 1 is basically wherever we have power n or n, you have to add 1 to that, right? So here if you add 1 to this one, we don't have to take this negative one, because if you take this negative one in this absolute value, it's going to cancel anyway, because whatever the value in absolute value is always going to be positive, so we don't need this one. Now let's go ahead and find it. Here we are going to have limit n approaches infinity, and then we are going to have x power 4n plus 2, but we have to add 1 to that power, right? Because that's a generic equation. Now if we add 1 to this n, this is going to multiply by 4, because 4 in front, there's a 4 in front of this n. So if I add 1, this is going to be multiplied by 4, so this is going to become 4, and we already have 2 right here, so 4 plus 2, that's going to become 6. And in the denominator we have 2n plus 1, so 2n, again if I add 1 to that, it's going to be multiplied by 2, so we are going to have 2n plus 3, right? Now we have to divide this one by original function, that is this one. Now dividing this one by this one is same as multiplying this one by its reciprocal. So if I multiply this one by its reciprocal, this is going to be 2n plus 1 over x power 4n plus 2, right? Now let's cancel everything we can cancel. If you notice, we have x power 4n, x power 4n in the top and bottom, so we can cancel this one. So we have x power 6 left, x power 2 left, and these are the only values that's left. Now let's rearrange in terms of like terms, like limit n approaches infinity, and we have x power 6 over x power 2 times 2n plus 1 over 2n plus 3, right? Since the limit is only related to n, so whatever the values except n, we can take this outside. So this x values, we can take this outside, right? X power 6 over 2, that's going to be x power 4, so we can take this x power 4 outside, and inside the limit we have limit n approaches infinity, 2n plus 1 over 2n plus 3. And if you notice, the powers are same because both of them are having n power 1. So whenever we have same power, the ratio of the power is going to be the limit. So here we have in front of this power 2, so 2 divided by 2, that's going to give us 1. So this limit is 1, right? So we have found the limit already. So after ratio test, we are left with x power 4. So whatever the value we are getting, that is less than 1. X power 4 is less than 1. Therefore, x is less than 1. If x is less than 1, the intervals of convergence is going to be -1 to 1, right? Now the question is asking for radius of convergence. To find the radius of convergence, we have to find the length of this one. To find the length, what we do is we take the highest value and subtract the lowest value from this one and divide by 2. So this is going to be 1 minus -1 divided by 2, and finally you will end up with 1, and that's going to be the final answer. I hope this helps. Thanks for watching.